Wireless LAN Professionals Podcast, episode 134.
Wireless LAN Professionals is a place to educate, inform, encourage, and entertain those involved in wireless LANs. This Wireless LAN Professionals podcast is an audio manifestation of these goals. Our host is a wireless LAN veteran, consultant, designer, and teacher, Keith Parsons. And now, the podcast for wireless LAN professionals by wireless LAN professionals.
Hello, Keith here with Sudheer Matta. Did I get your name right there?
Yes, perfect.
Oh, good. I like when they're spelled phonetically. It helps. Sudheer's with Mist Systems, and Mist has some new things coming out. Well, not out. They're already out. And I thought we'd just take a couple minutes here on the podcast and talk to you a little bit about some of the new things at Mist, Wi-Fi assurance, and your new virtual network assistant, and the whole topic of AI helping us improve our Wi-Fi.
Excellent.
Well, good. Let's just get right to it then. So here's the big broad question, and you can answer it with how Mist is doing this. But how can AI and the use of big data help improve our Wi-Fi?
Actually, it's really there are a few vectors. If we really step back and think about it, there are in any large enterprise of reasonable size, there are three personas in IT we're going after. There's the guys that are the smart people making the decisions on which vendor to pick, what config, what design. These are the architects. Then there's a team of people who are operating the network. Again, many times this could be the same people, but there's an operations element to it. And then there's a last but not least is a team of people that is taking frontline calls, help desk. So what we're trying to do is apply AI at every version of this, at every part of the journey here, right? So AI in operations, and now the virtual network assistant is adding AI to help desk get to better answers, more correlated answers faster. And really, that's the genesis of our launch this week, Keith, is around how can AI help desks? How can AI help operations? And then, obviously, with a lot of network architecture, design, deployment as well, there's some AI elements to that. So across those three spectrums, and so we can talk about what we're doing in each of those realms, right? So since the newest thing here is the virtual network assistant, let me talk about how AI is helping help desk. So
this is the folks at the edge who were not the engineers.
That's right.
They're not the ones who manage it on a daily basis, but they're the ones who take the calls when people complain.
That's right. And a really broad brush oversimplification of the types of calls they get are, people call in and say, hey, I can't connect to your network, or they call in and say, hey, your wireless sucks. And so now we took those two really broad categories of types of calls that come into help desk, and we said, could we run some machine learning on what type of connection failures exist out there, and what type of correlations to typical smart CCIE engineers run to arrive at the answers, right? And we took a lot of those algorithms and correlations and burnt it into an AI engine that we call a virtual network assistant. And you would ask a simple question as, hey, why couldn't Robert connect to the network yesterday? Or then you go to the next broad question on, hey, the wireless isn't good. I mean, and that's euphemism for, my throughput isn't good, my applications are slowing down, there's jitter, there's latency, all of that. So we combine a lot of that into some post-connection metrics. And again, same formula is take a bunch of algorithms for correlation and say, why is somebody's throughput not good? Why is somebody's latency, jitter, and voice experience not good? And so those are the two broad categories we went after. And the mechanism here is just ask a question in plain English and say, what is wrong with Robert's wireless experience yesterday or last week? And then run the algorithms, bring the correlations, and see if we can get to at least 20, 30, 50% of the answers and nip a lot of these wireless escalation calls at level 1.
So I'm assuming you have to do kind of a Siri or Alexa like front end to take a human speech question like Robert's Wi-Fi. We have to look up his MAC address to do a search, and then the answers also have to be turned from jitter was above some microseconds and turn it into English that the help desk guy can do something with.
Right, and as Steve Jobs always said, it's much harder to simplify, and so we did two things. So first, we put a natural language processing engine, NLP engine, on in front of the data, and so we could take a Siri, Alexa type experience, and so that in itself is a first time in the industry. It's not translating a hard query into a sort of a query style question into the database. We actually did put a proper full-on NLP engine in the system, and then the NLP engine, we think of it as two types of queries. It gets to ask complex queries. It gets to ask simple queries. Complex queries are, what is wrong with Robert's wireless experience from yesterday, right? And there's a lot of subjective in that, right? And so
it's a really broad question,
right?
So I mean, it could cover everything from the DHCP server to the DNSs down. I mean, it's a really broad question. So how do you then turn that into a super broad query?
No, we don't.
Do you ask individual questions, or you just open it up and say what was happening to this guy at this period of time?
Right. So to answer that, let me actually zoom out just a little bit. So one of the things of building sort of a modern cloud architecture is we keep data on a per user basis every minute, right? Every minute, every user, we're keeping data on all the state transitions, all the MCS transitions, all the coverage RSSIs. We literally have an RSSI map on a per client basis that's every 2 seconds apart. We have an MCS rate map on every client every 2 seconds apart as the data is coming in. So now that we have data at that granularity, we've created some metrics to answer the two broad categories, right? The two broad categories are pre-connection and post-connection experience. And so when somebody says, what is wrong with Robert's iPhone last week, we go through the pre-connection metrics and the post-connection metrics. We look at, okay, did the metrics for Robert violate any baselines within the organization, and for pre-connection and post-connection? And then we say, okay, we believe Robert has had an issue with time to connect, or Robert had an issue with throughput. And so the metrics are predefined on a per user basis. And so we go search on these defined 7 metrics and then come back and say, here's the correlation across those. So the metrics are predefined. So even though the question is broad, because we ingested a lot of data and diluted them to, okay, pre-connection metrics and post-connection metrics, we're able to come back and answer the question in a little bit more structured way.
So what kind of answer would that help desk person get based on that kind of query?
So let's say we said, hey, what is wrong with Robert's iPhone last week? So let's take a few examples. Let's say Robert was in an area, in a part of a building where there is poor Wi-Fi coverage. He's the CEO sitting in the corner office, and for whatever reason there isn't good Wi-Fi in his office, right? So the answer would come back and say, hey, we believe the primary cause for Robert's degraded experience is coverage, right? And then it'll say, this is the next piece is literally something we spent 6 months on, and it comes back in plain English, but it's a lot of algorithm behind it. Next, it would say, I believe Robert's coverage issue is either specific to him or it is widespread. Everybody on that floor, at that site, on that building are experiencing. And that's a segmentation thing. And so now IT has a choice, or help desk basically says, if it's a widespread issue, they automatically say, we got to escalate because Robert happened to call help desk, but everybody in that floor is suffering from Wi-Fi coverage issues. And so that segmentation happens first. And then we go into, then we look at a bunch of correlations. Let's say it is a widespread issue. Let's say everybody on that floor is having coverage issues. Then it goes and says, did an AP reboot? Did an AP fall off the network? Did somebody change firmware? Did somebody actually make a config change? Did interference increase? Did the RF? There's a whole slew of correlations we're going to go and run through and come back and say, we believe he's having a bad coverage because he's a victim of a systemic issue because somebody upgraded config and that took down the power levels down to 4 dBm or whatever it is, right? So the correlations are done in addition to what metric is the root cause. Make sense?
And yeah, that's I don't know what the help desk guy would do other than escalate that one. But what if the reverse was true and it came back and said, Robert's the only one having a problem?
Right. And so then we would say, then there is a tab in there that says, okay, if Robert is the only one having problems, then which AP, which band, which channel, and AP band and WLAN is he having issues on? And then that takes us down to, okay, so Robert is having an issue and we believe it's specific to his iPhone, specific to his device, because the area he tends to spend time in is not visited by too many other people, but it is his room or his area that's having low coverage issues. And that's one example of it. And let's say, let me take another one. And we had this one where we had a guest user come to our office and he says, for the life of me, I can't get connected to the network. And we're like, what are you talking about? All of us are connected on the same AP. Turns out on our guest network, the DHCP server stopped serving IP addresses, say, 3-4 days ago. Actually, it's been like that for a while and we just didn't notice. Nobody was getting on the guest network. So then in that case, the correlation would say, hey, the AP is okay, site is okay, everybody else is actually okay, but your guest user is having a problem primarily because DHCP on that WLAN seems to be an issue and not DHCP system-wide, right? So help desk is led down many different trails here on, they can either escalate, or let's say it comes back and say, no, we believe the issue is the OS version that you're on. Let's say they're using iOS 10.1.2 or 11.1.2 rather. And we say, hey, there's a newer iOS version, and in our metrics, we believe the newer iOS versions fixed it for users, then they would upgrade to the next iOS version, or vice versa, right? And so there's all kinds of trails that this can lead to.
So this third group that you're talking about here, the help desk people, in your research and talking to them, what's their next step? It sounds like a lot of the things that can be found using this intelligence really need to go back up to operations to solve.
Right. And that's why I actually carefully said and this is a journey, right? So the analogy here is, for us, it's IBM Watson like. And so IBM Watson actually took, many moons to hone in and get perfection. And so on our journey sort of towards our sort of nirvana network, what we need to continue to do is, hey, there is a bounded set of things you do to improve a user's experience, right? They are at a network level, they're at the environment level, the environment being everything outside the wireless network, which is DHCP, radius, and blah, 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 and then the client level. So, the journey here is we're going to actually map a lot of this to suggestions on possible, 3 or 4 bounded fixes and actions that they can take to remediate it. And so, yeah, we still have some more fine tuning to do in terms of truly dumbing it down so as one of our customers said, hey, my help desk guys are zoology majors that do this on nights and weekends. They can't spell RSSI. And to some degree, we are not there just to help them yet, but we are there where it's an enterprise and they get a little bit of Wi-Fi, but they're not, RF wizards.
Well, and even if you help you clear some of the issues out, that's an inexpensive first tier to hit anyway.
Right.
Going straight to operations every time with every support call is very expensive, especially if it doesn't correlate it.
Right.
So you're taking the things that Mist's been good at, showing all this information in your database, and I don't want to say dumbing it down, but you're making it simpler for a different tier of people to access.
Right. And one thing that we haven't talked about so far. So there are two categories of questions we're going after, right? One is these complex questions that are truly running machine learning data science algorithms to do the correlation. And then there's a whole slew of other questions that are pure, simple questions. As an example, how many iPhones do I have on my guest network? How many of the iPhones on the guest network are, I don't know, iOS 11.1.2? How many of them are iPhone 6s? And why is that interesting? Is a lot of times we actually get a teacher calls in and says, I don't know, half my devices couldn't connect to the classroom yesterday, and what is a MAC address? I don't know what a MAC address is. And so we actually created a fairly extensive high-speed database to be able to put lots and lots of data at rapid sub-second response. And so the virtual network assistant not only does a lot of data science, machine learning, complex queries, it also does a lot of simple queries. So help desk can actually get to honing and narrowing down on certain devices or just getting some answers easily. And that's the second part of what we've launched with VNA.
I'm intrigued by the amount of data you're having and the things that you could potentially do. Like one of the things I've shown when I'm, with customers is they don't understand how fast MCS is changing on a second by second basis, and you're collecting that data. I think a lot of people see their Wi-Fi connections as really stable because at the IP layer maybe they are, but at the physical layer their modulations changing all day long as doors open and people walk by. Is there any data that you could pull from that and show client XYZ is having a hard time maintaining, 64 QAM. They're always dropping to 16 QAM across the board and compare it from one device to another device or one area to another area?
We have not gone there, but we can go there, and this is some of the work that is still to be done. So today, what we do and what we maintain in the database, and it's coming to our UI shortly, is literally every 2 seconds we're able to show what MCS rates a client is using. And so you'll visually see the rate fallback algorithms, and we show them in sort of nice bubbles where bigger bubbles is lots more data, smaller bubbles is less data, but they're all aligned on an MCS chart. And so as the bubbles keep transitioning up and down, you're seeing rate fallback happening. It's an inordinate amount of data. We can't seem to hire fast enough to be able to run a lot of this, the data science on this, but that is definitely one of the things our customers are asking is, do certain clients have certain MCS behavior that maybe we should take out the, not just the lower data rates, but maybe the highest data rates, because they always seem to hit the ceiling and come back and struggle in retries. And so a lot more work left.
No, but you're thinking the right place. Is how do we maintain clients to be as happy as possible? And one of the things we've been stuck with for years is waiting for someone to call or complain, whereas you have the hard actual data there that can say, oh, we really need to lop off our high-end data rates because they keep attempting it and failing, and that takes a lot longer time than just being at a other place. A friend of mine, Sam Clements, calls this racing school buses, having them do drag races, because it's not what school buses are for. Our Wi-Fi clients don't need to go at 64. I mean, even 64 QAM. Most of the traffic can go at 16 QAM, and I'd rather have everyone have a stable something than an unstable attempt at going faster. and now you finally have data that can help support that.
Absolutely, yeah. And again, I think that's been, in our journey to getting here. We are now almost in our fourth year, in 3.5 years. The first 2 years literally was spent on building a cloud that can consume data at that scale, right? And so an artifact to that, Keith, this is something we're super proud of. For the last probably 70 to 80 weeks, over an year, every week we push new features to production, and that is because it's an architecture sort of built in 2015, 2016, 2017 versus an old architecture. And without that, we candidly couldn't have done some of this data stuff, because that is the foundation. And so it started there. And then we put this thing we call metrics, right? So metrics are how do you measure somebody's quality of experience? You could measure an application, how is it performing, all that kind of stuff. But we said we're hardcore wireless guys. How could we actually get wireless experience quantified? And that's where one of the graphs we have is every user, every minute, average RSSI is what we put in the UI. What we have in the backend is every user every 2 seconds. We're trying to tone that down a little bit, but every 2 or 10 seconds, their average RSSI. So it started with data, then went to metrics, and then started the true data science work on how can we take this and actually materially deliver a better wireless network versus just more dashboards and monitoring.
How do you take that information then? And this is kind of a philosophical question, where you have big data, you might have the ability to say, we think to solve this problem in this side of the building, we need to adjust power level, channel, etc. Something that would, in Cisco world would be ARM, and have it automatically make those changes. Or, I mean, that's putting a lot of faith in your AI. Or is there a human in that loop saying, here's the recommendation, but someone else hit the button?
I think the answer is somewhere in the middle. So Cisco world is RRM. Sam Clemens would be disappointed in you. ARM is the Aruba world. So,
well, they're RRM, ARM, they almost sound the same.
That's right. But today, here's a simple difference in the RRM that we have arrived at and the RRM that we know of, right? So historically, RRM had, hey, I'm going to react to change as it happens, right? And we do that too. Let's say an interference source is brought in, you detect, channel, SNR, average noise, all that stuff goes up, and then we move to a different channel. We do that. But what the other thing we do is every night, 2 a.m., 3 a.m., we take 24 hours worth of data and we say, can I make that network better for the 24 hours? I'm seeing, a certain set of APs that are around honeypots. The system doesn't know that it's a conference room. All the system knows is that AP sees a lot of traffic, during a long period during the day. And so we take 24 hours worth of data, and then we come back and correct ourselves. And so it's not doing database at 2 a.m. That's what used to be earlier, where some people just couldn't execute RRM real time. And so they would just do once a day, and that was based on whatever the situation was at 2 a.m. The good news about collecting all this data is we execute RRM based on 24 hours worth of data. That has made a real difference. I mean, I can count on one hand of all the networks we have. I mean, we have one customer, 5,000 APs, another customer going to 15,000 APs. I'd say 99.9% of our networks are running RRM enabled, no fixed channels. And it's been a very interesting ride. We sort of reinvented RRM silently and surely, but there is more. You're absolutely right. Could I actually tweak channel width, right? Dynamic channel width, like Cisco and Aruba are talking about. Could I tweak channel width on a select set of APs because they're seeing more? Could I tweak, take out some DFS channels because they, certain set of APs or one floor seems to be hitting radar all the time. So lots more to be done. And it's just we can't seem to, again, as I said, hire fast enough. But the good news is, our philosophy has always been build on the shoulders of our customers. And as customers are coming in, we've been fortunate and blessed to be in a lot of Fortune 50, Fortune 10, Fortune 100 accounts. We're getting there as fast as we can.
Let's go back a little bit to that statement, 70 to 80 weeks. You roll out an update on a weekly basis?
We do. And as an old controller product manager, for me, it's just unfathomable. And so let's actually talk the anatomy of that, right? So the anatomy of that is our cloud is truly microservices segmented, right? And what that means is we have a separate microservices for RRM, a separate service for zone analytics or location engine or whatever. And so now that we have one cloud that is extensible, running on a high-speed messaging bus, we run on Kafka, and that's taking sort of just like Twitter and LinkedIn and Amazon 3.0. So then what that gives us the opportunity is, we're going into a very large deployment, 3,000 APs with a retailer, and they saw that in the stores that have one or two APs, we could do better in our initial channel selection, whatever, right? And so we're pushing an RRM update for them, independent of the rest of our cloud. Tomorrow, every Wednesday we do this. And so like last week, what the update we pushed out is our APs always required the native channel to be open to go to the cloud, and now our APs don't need that. And so we can actually, we can put a VLAN on the APs so they can be on a tagged VLAN to get to the cloud. I mean, every week we are materially pushing new features, even like 11K update or 11V update, all those things in line while we have, tens of thousands of APs, thousands of customers, actually thousands of sites running this production networks, right? So it's been a real refreshing change, just the architecture, the way it was built.
Was there fear that you're going to break something along the way? I mean, obviously after 70, 80 weeks of it, you're feeling pretty comfortable that you got this down. But that most companies would look at that and be a little gun shy of that fast of updates because, bugs are bugs, they exist.
Right. And engineers haven't suddenly transformed themselves. We humans write the bugs. And so two things. First, did we have issues probably in the first 20 weeks or so? We did. We never took down a customer data network, meaning they were never able to stop passing data, but we've had issues where guest access wouldn't work for 10 minutes or something like that, and so we learned. I was always afraid that one of our Fortune 50 customers would come and say, I can't have you be doing this on my network, right? That is the big fear, just like you said. And so far, the good news is, I mean, as I said, our largest customer is probably running about 5,000 APs in about 300 sites across India, Japan, Australia, Europe, and the US. And and so far they've not told us once, can you please slow down? The only week, there are probably 5 weeks we took a break. We took a break the week of Thanksgiving. We did not take a break the week of Christmas. We took a break the week of Thanksgiving primarily because we have several large retailers who just said, why do you want to mess with fate? Right?
Because this is not the right week.
That's right. It's just don't play with fate. I mean, you've been blessed and lucky. But otherwise, I mean, even Christmas week we pushed, and so it's the good. Here's actually one thing I found, Keith, that is the benefit of doing this. The benefit of doing this is that you don't accumulate a lot of features that need massive system testing. You deliver in bite-sized chunks. This is the lean enterprise, lean engineering model, right? And so you deliver in very small bite-sized chunks, right? So 1 week we deployed, I want to be able to schedule my SSID, right? Something that's completely in the cloud, but it impacts users. And so from the next day on, our users were able to schedule their SSID so they can turn off their guest SSID during nights and weekends, right? But it is a feature that came in line, and they were able to use it the next day across the entire customer base, right? But we do. The other advantage of this is we have the luxury of launching stuff into production without exposing to customers and being able to run the algorithms and bake them on customer networks, especially data science algorithms, without the customers having to see it, bear the brunt of any failures along the way. And so a lot of research and development happens on production networks. As again, the moral, the big rule here is the first time you lose the trust of the customer is the last time they'll place trust on you, right? And so far we've been very, very blessed.
So how do you that last statement you just made, where you have access to all of this production data, but you like how do you physically change code without changing code? I mean,
yeah. So think about it this way, right? So let's say I want to run a new correlation algorithm. What we do is, so a lot of the customer data resides in some high-speed databases, Cassandra, Elasticsearch, and then some low-speed, slow retrieval databases like S3, Amazon S3. So let's say the data science guy wants to now do better correlations on finding user problems. He essentially accesses this data via API and runs his algorithm in a separate topology without creating and adding data to the customer's databases. So he has his own playground where he essentially takes and accesses this data and takes this data over to his playground, and he's now able to run algorithms on live data, but not necessarily be burden the live networks for his algorithms, right? I don't know if that makes sense, but each one just create playgrounds, taking in live data, running their algorithms. The moment they feel comfortable, it scales and it adds value, then we bring it back add it to production in one of the weekly pushes.
That must be a big scheduling nightmare, thinking of all the things you'd like to add, the things you're working on, what stage they're in, and then when they get rolled out and which week they go in. That's a big project management.
So it's actually it is actually interestingly not. Again, for me, when I first came in, again, old curmudgeon wireless guy, wireless controller product manager, I was like, man, how the hell am I going to maintain PRDs and all this stuff for this kind of fast-moving train? Over time, what we figured out is we just deliver in bite-sized chunks. If somebody said, I want fast roaming, we'll say, okay, I'm going to do 11K, and I'm going to do 11K neighbors first, and that's it. And then 11K neighbors with, okay, I'm going to hand over data. And so it's really comes down to bite-sized chunks. And so essentially we take a monthly approach, and we say, this is the big rocks for the month, and hey, all of you go have fun, and whoever catches the first train on the first Wednesday, second train on the second Wednesday, it's up to you. And the big piece in all of this, the cardinal rule for all of this is you have no manual QA. You have completely automated a lot of the quality assurance and system testing here. And that's what we have done. We have a QA team. We've not hired QA guys that put laptops on carts and running around. You ask them a question twice, they will automate it, right? And so the entire QA team is a series of API programmers and Python script programmers whose job is to automate any new development happens. They automate the test of that. So you build for the cloud and you don't build for the old world. That doesn't mean we won't and don't do Wi-Fi testing, honest to goodness client compatibility and stuff. But again, since it goes back to bite-sized chunks, you just do small things at a time, and you don't break them.
Well, I am quite impressed. That statement alone, that you release weekly for X number of weeks, also means you trust your stuff. And I like the bite-sized chunks. If you only change one chunk of code, you don't have to test that one chunk, not a monolithic kind of change. But you live that whole. Oh, by the way, for our audience, you want to explain what PRD is?
Yeah,
I mean, I know what it is. I worked with product managers before,
that's right.
but not everyone has that kind of relationship. So what's a PRD in a
Yeah.
controller world?
So a PRD is a product requirements document, and because in a old style world, in a controller world, we got to release controller images maybe every 3 months, every 6 months, every 9 months, and because they were materially network downtime impacting, we didn't get the luxury of just throwing images over the wall for our customers. And so what we would do is we'd gather, okay, all the customers that are asking for some feature requests, some of my innovation agenda items, and we'd blend all of it into a massive, okay, this is the product requirements document for controller release 8.1.6 or whatever it is. And then that's when engineering goes off and starts working on it. QA goes off and starts working on it. Then there's test plans, and there's this entire process. It's called the waterfall model, where every 6 months you take a material step forward, right? And the issue with that is it is one blob of code, and consequently, if some guy needs to change one small thing just to check that he hasn't blown up something else of the system, they have to retest the entire system test. And that's why old world architecture took so long to release code. But when you go sort of lean engineering, it's a much more palatable control. And by the way, we document our weekly releases on our customer portal, and so you can see on a weekly basis. Sometimes we actually you don't see a week noted on the dashboard. That's because we were probably updating back-end stuff that didn't have user visible impact. But we haven't missed very many Wednesdays.
Well, very impressed. Thank you for your time. This was very enlightening to see where Mist is going, and it's an impressive process you've built there over the last 3.5 years at Mist, and adding AI to the end is what we're after. The goal here is just to make Wi-Fi as good as possible, and glad that you guys are along for the ride.
Thank you, Keith. I really appreciate the opportunity. Again, a shout out to you and the entire WLPC team. I think I feel privileged and blessed to be part of that community, because I think at the end of the day, the crusade of that community is, if in 2 words, operational simplicity. If we can simplify operations, I think we can, the world can just go Wi-Fi and just be done with it, right? And so that's our crusade. It's aligned, and we're excited to be part of the WLAN Pros podcast and just the WLPC community in general. Thank you for the opportunity.
Thank you.
10 Talks.
My name is Rich Hummel. I work for Acceltex Solutions. I am from San Antonio, Texas. So therefore, I am wearing the requisite cowboy boots and camouflage that you are issued when you move to the state of Texas. I don't know a lot of people here, so just to give you a little bit of my background, I spent most of my life as a working engineer. I started working on 3-dimensional radar systems in the Air Force, moved through a lot of different technologies, got my degrees in engineering and management, and then, like a lot of people do, especially engineers, when they find out how much salespeople make, I said, you know what? That sounds like a really good idea. So I'm going to talk at a very high level about antenna design. This is really more about the things that we have to consider when we're designing an antenna so that it looks and functions the way you need it to when you're doing an installation. So, as most people know, when we're talking about RF, it's as much an art as it is a science. Just to give you a little bit of history about RF or Wi-Fi antenna design, when we first came out, when Wi-Fi antennas were first being designed, it was for a single radio, it was a single frequency, and that's pre-2000. Then we went to the early 2000s where we had a single antenna array. Okay, we were supporting 2 frequencies, obviously, but the elements were dedicated frequency elements. So if you had an antenna array, it would have elements 4, 2.4, and 5 gigahertz. Okay, and then you might have, depending on the AP, single or multiple elements. Now we live in the dual band antenna realm. We have a single antenna array, again, supporting 2 frequencies. The difference is that the elements will be both 2, 4, and 5 gig. And we will have, in most cases, a single antenna element per AP. So when we talk about the things we consider in antenna design, obviously the first thing is going to be the application. Okay, what type of antenna are you going to need? Is it going to be, in general terms, omnidirectional or directional? What frequencies are we going to use? We see that the frequencies are changing constantly depending on the next release of the 802.11 standard. What type of gain do you need? Are we looking at overlapping or asymmetrical coverage areas? Beam widths today are critical. Everybody wants that sharp 3 dB edge. And antenna manufacturers are constantly trying to sharpen that edge because in high density environments, that makes your job a lot easier. Polarity, the majority of antennas out there are going to be vertically polarized. If you're in a high noise environment, you might want to consider horizontal polarization because your signal will cut through the noise that much better. Isolation between the elements, are there environmental conditions that need to be considered? Heat, cold, moisture. All of those things combine into the different environmental factors that we have to consider. Are we talking about pigtails, or are you going to be able to directly connect that antenna to your radio? In most cases today, there's going to be a pigtail involved. Rubber ducks, really, if you're going to use rubber ducks, you're probably going to use the internal antennas. Grounding plane is always going to be important, as well as the input power. Now, the second thing we consider after the application is the type of element, okay? We all know that, again, the fact that RF doesn't always behave the way it's supposed to, that the theoretical versus the actual implementation of the antenna is going to vary. Theoretical, you could have all the numbers correct. Then you build the element, you hook it up to the radio, and you go, yeah, and it doesn't work anything like you thought it would. Is that element going to be a printed circuit board or a discrete metal component? And we also have to consider the isolation for those individual elements within the array. When I was in engineering school, one of the first classes I took that gave me a real bear was my second semester of circuit analysis. So they would give you this circuit, and you were supposed to trace that signal through the circuit and develop an output. In most cases, in theory, after doing page after page of calculation, it looked like a nice lineup of those dogs eating out of the bowl. Then they would say, okay, now take it to the lab and test it, and it looked like everybody fighting over that same bowl of food. So what we do is we try to reduce those variables in practice. So we put it into our anaerobic chamber, also known as the antenna torture chamber. What that is a perfect lab environment. Of course, we don't live in that lab, but this gives us at least a starting point. When we talk to you about antennas, we have a place to start the discussion anyway, as far as what that beam pattern is going to look like to help you provide the proper coverage. This is an example of the 2 different types of omnidirectional antenna elements that you can find in most antennas. If you bust that radome off, you're going to see either a printed circuit board or discrete metal elements. A lot is going to depend on what you want that finished antenna to look like as to whether or not you're going to use a printed circuit board or a discrete element. You can obviously go, depending on the type of antenna again, and the gain and all the other characteristics that we've talked about, you might be able to get a more compact design using a printed circuit board, but that's not always the case. The third, is radome design. A big thing today is aesthetics. You can't just go and hang an antenna anywhere, particularly if you're talking about a hospital or a school. Number one, the architect may say, no, I'm not going to allow that to happen. Second, it might create a problem. If you're in a warehouse and the radome is too big and too bulky, you might get it hit by a forklift, someone trying to do their job. The size of the antenna is going to depend on the characteristics of that antenna. The higher the gain, generally the larger the element. And again, frequency, because an antenna element is usually a fraction of the wavelength, it's going to impact the size. The material of that radome is also important. If you're going outside, you want to make sure that that radome has a UV stabilizer in it. Otherwise, what's going to happen is a couple of years after you deploy that nice white antenna, it's going to look this ugly shade of yellow, and somebody's going to place a phone call and say, you know what, I really don't like the way that thing looks anymore. Can you please come and change it out? The color, again, it's going to be up to the architect or whoever has the final sign-off on the design. I worked on a project, not necessarily with an antenna, but for an enclosure where people just couldn't decide on the color. So what we've gone to now is skins. Rather than trying to paint something or build the color into the plastic, we wrap it in a vinyl skin. If something happens, somebody doesn't like it, we take it off and we try another one. The backplane, of course, has to do with, the radiation patterns that we're going to end up with. If moisture is a problem, we might want to consider putting weep holes in that antenna because condensation now has a place to bleed out. If it doesn't, what you eventually end up with is a rain gauge. Again, aesthetics is going to be one of our keys, and it's so important, we put it first and last on this page. Next thing to consider is mounting. Like I said, I was a working engineer for a lot of years, and I've been in this business for a long time. What often happens is the last thing people think about, especially young, inexperienced engineers, is how am I going to mount this thing? Okay? These are the things we need to consider, indoor or outdoor. If we're going to articulate azimuth and elevation, are they both necessary? What do I have to mount it to? Wall, pole, ceiling, or combo mount? What type of material are we going to make it out of? And here's a big one. If it's going outside, what kind of wind load are we looking at? Otherwise, that antenna could turn into a flying saucer really quickly. What could be next? We're looking at tri-band antennas. We heard before about whether or not 900 megahertz was actually going to be implemented. If it is, we're going to have to build those antennas to match. But wait a minute, we've been talking about this all day. We have to wait for the radios. More importantly, we have to wait for the clients so that our antennas are going to be able to speak as efficiently and effectively as possible.
Thank you for joining us for another episode of the Wireless LAN Professionals Podcast, the podcast for wireless LAN professionals by wireless LAN professionals. Be sure to follow us on Twitter at Wireless LAN Pros for all the latest news and updates, and also connect directly with Keith on Twitter at Keith R. Parsons. Head over to www.wlanpros.com for this episode's show notes, as well as the latest in all things Wi-Fi.